Okay, it's 3 o'clock sharp, and I would like to thank you all for being here today for this webinar session, which is going to be recorded. I am Valentina Chimici, and I am product owner of the Science Kit that we will be seeing today together. And today with me, we have Angela, my partner, and she's responsible for sales and resellers for education. And then we have our partner who made this possible today, Rato Education. And today from Rato, we have Peter. You can try to unmute yourself. Okay, great. So let's get started with the presentation. I hope that you can see the slides. So today the session is going to be about teaching physics using Arduino and Science Journal. And once again, this session was possible thanks to Rato Education. Okay. Then it's time for Peter to give us an introduction about Rato Education and the kind of activities that they do for the education world.
Yes, hello. Can you hear me?
Yes.
Okay. I will do this in Dutch because most of the personnel are Dutch speaking. Hallo iedereen. Ik ben Peter van de Vreek van Rato Education. Bedankt om deel te nemen aan dit webinar. Misschien zoals de meesten misschien wel weten, zijn wij verdeler van de producten van Arduino Education. Wij richten ons vooral op stemgerichte producten. De meeste van de producten van Arduino Education kan je vinden op onze website, ratoeducation.be. Vandaag gaat het iets meer specifiek over de Science Kit van Arduino Education, die je momenteel ook in promotie kan vinden op onze webshop. Alvast bedankt om deel te nemen en neem gerust contact als er vragen zijn. Dan kan je ons contacteren, zowel mij als Jeroen. Oké. Dank u wel.
Thank you, Peter. So now I'm going to walk you through the webinar today, so our agenda. So there is a question in the chat. So yes, the video will be recorded and distributed for you to watch later on. Today's agenda is going to be like pretty easy. We had already the presentation, and thank you again to Peter. Then we will discuss about what is Arduino and the kind of activity that we do and we promote with Arduino Education or STEAM classes. And then there is going to be an in-depth session on the Science Kit Physics Lab, which is a kit that we co-developed with Google. And at the end of the session, we're going to have a short Q&A if you have any questions, any doubts, anything that you want to ask us. And we're here to answer to all your questions. So probably most of you are already familiar with Arduino as a company, and Arduino is an open source electronics platform based on easy to use and easy to program hardware, software, because we provide also the community with free open source software and documentation. All our products are documented online. You can find files online. You can find examples. You can find everything you need to get started with Arduino really. And Arduino exists since 2005. But from the beginning, we structured the business a little bit differently as we move toward the future in a way. And so now Arduino has three core businesses within its soul. The first one is education, and Angela and I are representing Arduino Education today. Then we have a part of the business that is more based on makers, and then IoT, so Internet of Things, professional kind of usage for Arduino products. Of course, the main mission for Arduino is to enable everyone to innovate by making complex technologies simple to use. In fact, when Arduino was started, it was used as a tool for designers that weren't very knowledgeable about electronics. But this tool allowed them to create simple devices which use the sensors and actuators to create like interactive devices. And today, Angela and I are representing Arduino Education, which is our one-stop shop for everything you need to get started with STEAM education in your classroom. So we can provide you with educational products, digital culture dissemination, because we work quite closely with universities and research groups, for example, to enable everyone to use digital technologies and implement them in the classroom. And of course, we also produce high quality content, which is one of our main strengths in terms of what we can offer to you and to your classroom. So this is our education portfolio for 2019. We have launched during BET this year in London 3 products, the CTC Go, which is targeted at upper secondary education, our fundamentals certification, which is an exam online that you can take to get certified about your skills on Arduino. And then today we're going to discuss about the Science Kit Physics Lab, which is a brand new product that brings some news and opportunities to the classroom, especially for science teachers. So the Arduino Science Kit Physics Lab is the first Arduino kit for teaching sciences. And of course, it's not only focused on science per se, but also it lets you teach how to develop transferable skills, critical thinking, problem solving, and all these skills that are required in the 21st century skills for the future. And with this kit, you can experiment forces, motion, magnetism, conductivity, everything everything is packed in a box, and you can use it for like experimenting with your classroom. And this is the first Arduino kit that doesn't require any prior knowledge on electronics. In fact, it's the first Arduino plug and play kit that you can use. Basically, you have to plug the hardware to a power source. You connect your smartphone or tablet to your board, and you're ready to go. You get immediate feedback from the data that you can gather from the hardware online. And this kit is themed, so we picked up something that could be engaging for the classroom. So we decided to explain the physics behind the carnival or amusement park rides. So we will explain the physics using our hardware. And for example, this is an example of the experiments that are included. So with this, you can basically monitor the acceleration of the board, and it probably reminds you of the drop zone, so the tower where you get dropped from up above, and so you can measure the acceleration of the board. Okay, so this kit was developed with Google, is currently aligned with NGSS and National UK Curriculum. But for example, if you are interested in bringing these kits to your school, we are open and we can add additional curricula to the kit. The idea behind the kit is that you get data from your hardware, you record this information, you get graphs, and then you can do an analysis on the data that you can gather from your hardware. And it's also compatible with Google Classroom. So for example, if you're a Google certified school and you get, for example, Chromebooks, or you have all the Google suite, you can use it with this kit. And to better explain or give you a gist of what you can do with the kit, I'll show you this short video that we shot in London.
The Arduino Science Kit Physics Lab is a one-stop shop for all the experiments that you can do. It's all combined into one box, which makes it really accessible. The students can just pick it up, get it done, fit it together, and boom, they're in.
So in a way, the Arduino Science Kit is a brand new product that brings a very new approach to science, because you get the same feeling of getting together a piece of hardware, which is way easier than the regular Arduino kit. And then you can get started immediately. So you get an immediate feedback from what you can do and the experiments that you can run. The kit is based on the Arduino MKR Wi-Fi 1010. Each kit is recommended for 2 students and a teacher. And for example, if you purchase multiple kits for a classroom, then you can stack them together online, and you can have like some kind of digital management of the classroom. So you have all your students online, and they can access to the platform independently. And you can run up to 9 experiments that are documented. But then at the end of the day, as any other Arduino kit, the creativity and the imagination is your limit, because then you can reprogram, for example, the board, and you can reuse it multiple times. These are the experiments that are included. The main area covered by the kit are electromagnetism and thermodynamics and kinetics and kinematics. So one is more focused on tabletop experiments that you can run very easily, and the others are more based on motion mostly. So everything is themed, as you can see. For example, we have the electric fortune teller, the haunted house Termin, the Gravitron, or other rides that you can find in a regular carnival in an amusement park. But another thing that we wanted to highlight with this kit is that it's really easy to use in the classroom. It takes you like few minutes to set up. So this is one of the experiments that is called the pirate ship. And the idea is that you can measure the momentum of a pendulum. So you get the science carrier board. This is the board. You stick it on top of the carrier board, and then you take these 2 sticks that are the mechanical parts, and you're pretty much ready to go. The good thing about this kit is that you can easily reuse what you have in your household or in your classroom. For example, we're using a pencil to create like a pendulum. So you don't have to buy additional materials, but everything can be found easily. And for example, for the power source, you can use either like a LiPo battery, as I will show you later, or a power bank, the one that you use for example, your smartphones and tablets. And as you can see, you can get real data stream in real time. So the feedback is immediate and everything is shown thanks to this graph, which is in the app that is called Science Journal. That is your companion for the experiments. And in each Arduino kit, you will find, first of all, access to the exclusive online content with teachers' guidance notes, students' worksheets, tutorial, pictures, information on how to troubleshoot, for example, but also additional experiments that you can run after you're done with what you did in the classroom. Of course, you get also access to the Science Journal app that is currently available on Android and Chrome OS devices that support Android. Basically, you can easily connect your hardware via Bluetooth, and you get a set of sensors that we included in the app as an integration. And last but not least, all the materials can be shared in your Google Classroom. So for example, if you're a Google Classroom teacher, you can assign to your students an assignment with all the activities that you want to get them done by whatever date. And now it's time to show you how it actually works and how easy it is. So this is the carrier board. So this is like something that we designed specifically for this kit. And you can find like inputs, outputs, sensors already built in with this carrier board. Let me find like the right. Okay. So you have an IMU. You can measure resistance, voltage, and current. And the board is pretty solid, so it's very good for the classroom. So you get your MKR board and you stick it on top over here, like this. There you go. And the hardware is done. Then I can add, for example, the silicon standoffs for running tabletop experiments. So let me show you this. As simple as that. And then, of course, you have to plug the hardware to a power outlet. So, for example, for today, I'm using a LiPo battery with a GST connector. But you can also use, for example, power bank, the one that you use for your laptop and tablet. So now this is on. It's a little bit blurry, but you get the idea. So this is already working. The next step is to connect the hardware to my app. I have to turn on the Bluetooth. Okay, the first time I need to. Okay. So once I turned on the Bluetooth, here we are. This is my board, MKR Science, and then there is like an ID that is connected to my board. And then let's say I would like to measure the accelerometer and on the XYZ axis, and then the linear accelerometer. So I go back, and then I connect the board. So right now, for example, I'm measuring the accelerometer on the x-axis. So as you can see, the graph is showing the movement that I'm doing. And the animation also allows you to understand what kind of movement you're taking. So which one of the three is the x-axis. I can do the same, for example, with the y. Oh, sorry. Okay. So I'm able to see in real time the information that I'm gathering, that I'm collecting. Unfortunately, is a little bit slow because this is a mirroring from Anna. But generally speaking, for example, this is the linear acceleration. So if I remove the standoffs, and for example, I move the board, I can see all the variation in the acceleration. And it works pretty much immediately, just it's a matter of like picking the battery and you're ready to go. And it works over Bluetooth. Something else that I would like to show you very quickly is the online platform. So you get, for example, if you're a teacher, you get a dashboard. And you can add several students, for example. Each kit allows you to add two students, sorry, per kit, but you can then add multiple kits and then add multiple students as well. You have a glossary section that we developed with a physics teacher, and then you have access to all the experiments that you can do, basically. So there is a getting started section where you get an introduction about what tools are included, what you can do with it, a general overview for getting started in the classroom, and many other information. So for example, pictures on how to connect the battery, and you can either use, once again, a LiPo battery as shown here, but also connect a plug and USB cable, so you can connect it to your laptop, for example, if you don't have to run motion experiments, or use a power bank. And then we help you with troubleshooting and additional information. Everything is documented, so if you have any issues, any questions, everything is online. And of course, as all our products, you get support online and warranty. So let me show you also, for example, one of the experiments in here. So the pirate ship is the one that we saw in the video. So of course, students won't see the teacher's guide. This is something that is linked just to the admin account. But then you get, for example, of the glossary, learning outcomes, a little bit of historical information about the ride, in the amusement park, and then you get the background on when, for example, pendula were used and where they were documented, and then you get all the sensor setup, but also the physical setup with step-by-step instructions. And information, everything can be printed, so if you want to use it in the classroom, you can use it as well. And then you get information on how to collect and analyze data. And last but not least, you get additional inspiration on, for example, for the pendulum, you can increase the length of the lever for your pendulum. So we guide you through that, and information about results and analysis, student worksheets, and finally, additional questions that can be used for exercises and so on and so forth. So coming back to our slides, I think that Peter can give you a bit of information about the promo that they're running today for the webinar.
Ja, momenteel hebben we vanwege deze webinar de Science Kit in promotie staan op onze website www.ratoeducation.be. Indien gewenst kan je gewoon ons contacteren. Indien je een offerte wilt of voor meerdere stuks, neem je gerust contact. Dan kunnen we daar een aangepaste offerte uiteraard voor maken.
Great. So one last thing is that we have one of these experiments that is visible for all. So if you want to get started and give it a go, you can go to this link and you can access to the free experiment. So you can see what's going on, how it works, how is it, what kind of information you can find in the experiment. You just have to go to bit.ly/physics-lab, and then you can access this experiment and you can have a look at the information that are online. And I think we're good. And now it's your turn. If you have any questions, information, it's your time. We can use the chat to write down questions. Yes, other sensors can be added. Let me switch back to the video. Okay, so as you can see in here, you have three inputs. The first two have this connector, which is the one that is commonly used by Seed Studio group. So the connector is universal and is compatible with Seed Studio sensors. The only difference with the sensors that we include on with the kit is that basically you will only get raw data from this. So just like a general number is not going to be used with unit measurement or measurement unit. So for example, you will get 200, 300 is not filtered in any way. But something that you can do, for example, is to get the raw data, download it, export it as CSV, and then you can manipulate the data within Google Drive, because everything is integrated with the Google suite. So absolutely yes. So the sensors that are included are light sensor and the temperature sensor, and then you get also in here. These pads are conductive and can be used as sensors to measure resistance, current, and voltage. And you also have over here the IMU, which is the accelerometer and gyroscope. And of course, then you have your regular Arduino can be reused many, many times, and we provide you with the code if you want to reprogram it to factory to reset it, basically. Can you measure distance? Well, if you want to include, for example, an ultrasonic sensor, and you have the groove sensor version of it, absolutely yes. You can also be able to reuse the Arduino board as you wish. So if you are familiar with Arduino programming, then you can simply do that. So you remove the board and use it as a regular Arduino. They're radioactivity sensors. No, they're not included in the kit. But for example, if you have them in the classroom and they mount the connector, the groove connector, once again, they can be added. Yes, so Science Journal is, let me switch to the other webcam. So the Science Journal is an app and a community, and online you can find their own community. So you can not only use the Arduino hardware to run experiments, but you can also use your phone or tablet. Therefore, there are already some experiments in addition to what's already included in the kit. But then you will use your phone or other sensors. Okay. If you don't have any other questions, oh yes, the magnetometer is included. So we use the accelerometer gyroscope in the IMU to measure the magnetic field. Yes, we have the magnetometer. Okay. So if you don't have any other questions, I would like to thank you all for joining us today. In here, you can find our information. You can either contact us at sciencekit@arduino.cc, or you can contact Rato Education. Once again, thank you for hosting us today at info@rato.va. And we are available for answering your question. The video will be online soon. And thank you very much for your time.
Thank you.
Thank you very much.